This is a cool venue. I love
this. It is.
And I love being back in front of live humans again. You know, I mean, I'm thankful that we got to do our job from home, and so we could still present, like, to screens. This is a lot more fun to actually be in front of humans, so thank you for being a live studio audience. Good afternoon. Well, I guess it's still morning, isn't it? I don't even know what time it is. I'm very confused right now, time zone-wise. My name is Nate Schutta. I work for VMware. This is my wonderful friend and colleague, Jakub, also VMware. Best way to describe me, I guess, is architect as a service, because I go places and I talk to people. Although I will admit, the first time someone called me that, I realized it might not have been a compliment when I sounded the acronym out in my head, and figured they might actually have had ulterior motives for calling me architect as a service, but I'm going to try to take it for as much of a positive as possible. So we are going to try to swap back and forth here for live coding purposes as we go. We'll be around if you have questions when we're done here, but I've been doing this software and architecture thing long enough to remember when it used to be simple. I won't say it was easy. It's never been easy, but it was simpler. You know, we had a monolith or two. If my clicker will decide to behave here, maybe.
You can use space, by the way.
I know I can use space, but you know, that's like the wrong way to do it when you're professionals like us. So there we go. Now it finally clicked in. You had a monolith or two. You released periodically for some value of periodically, and we all worked near one another, or at least within walking distance, but that's not the case really for any of us now, is it? I mean, the reality today is you don't have one or two or three applications. You've got dozens or hundreds or perhaps thousands of services. Some companies, how many services do you have? And they're like, we don't know. We don't know, because new versions are coming out all the time, and we're changing things and dropping things. Your team doesn't all sit in the same place anymore either. You know, I mean, that was obviously exacerbated over the last couple of years during the pandemic, but this trend has been ongoing, frankly, since the late 90s. You know, and it's only gotten more accelerated here in the last couple of years. Now, being an architect has never been an easy job. There's no getting around that. It's gotten a lot more difficult now, though, because we have these massively distributed applications. You've got teams that are scattered all around the globe. And what you realize really quickly is, man, we're spread really thin in the architecture ranks. You know, when I was a young, naive developer, I thought, wow, our architects are terrible, because they just sort of like show up at random times. They like spin into the project room. They write a bunch of stuff up on the whiteboard, and then they spin out, and you're like, you know, dazed and confused, and like, who was that? Oh, that was the architect. Oh, okay. Don't worry, you only see them periodically, every couple of weeks or so. It's like, you know, a fortnight-like thing. And then I became an architect and had 30 projects dropped on my head that same day, and I realized, oh, okay, I understand now. There's not enough of us to go around. The reality is we cannot be all places at all times. We cannot be involved in every single decision. We don't want to be involved in every decision. But we can empower our teams, and we can use distributed decision-making to our advantage. Our job is to establish principles. In a perfect world, what we're going to do is leverage the power of defaults. This concept is powerful enough that it actually won people a Nobel Prize. This is what sits behind behavioral economics. All right, so Richard Thaler won a Nobel Prize for basically saying, if you want to get somebody to do something, make it easy. I mean, that seems kind of obvious. But hey, you know, he came up with it, so there you go. As architects, we can use that to our advantage. Now, I know that may be a little strange. Why am I talking about the dismal science here in a computer science context? What we are trying to do as architects is take advantage of the power of defaults. What we are trying to do is make the right choice the easy choice. What you discover very quickly in these environments is distributed systems all have very similar needs. We need to monitor what's going on. You know, in the old days, we could just put a breakpoint in. We could just walk through the code. It wasn't that hard. We can't do that anymore. In fact, there's a decent chance that our system's calling stuff that we don't have any access to. It's going to have some circuit breakers for when things inevitably go wrong. We're probably going to want some consumer-driven contracts in place so we don't inadvertently break somebody that's using our stuff. You might need to use gateways or streams or figure out how to externalize your configuration. Maybe you're going to do some functions. How do we find all these services? How do we do load balancing? The moral of the story is there's a lot of moving parts here, and you cannot afford to reinvent the wheel in every project. That way lies madness. That way makes suburban sprawl look beautiful. One of the things that I really appreciate about Spring as an architect is it allows us to focus on these critical design decisions that matter, while giving our teams the ability to solve those critical business problems that they're tasked with every single day. That's what our customers want us to do. Put code in production. Solve my business problems. Give me features, give me functionality, do it reliably, do it repeatably. There are bountiful ways to fail in distributed architectures. Spring can help. It also helps us get a better night's sleep, which is something we appreciate when we're on the road, to say the least. At the end of the day, friends, this is all about delivering business value to production. That is what we are paid to do. All right, so what do we even mean by Spring? I take for granted that people understand these things, and then I realize, well, you know what? If you came into our industry 5 years ago, you probably aren't familiar with Spring, or it may not be something that you were taught. I mean, I grew up with a lot of these technologies, and so looking back, if you think about all the things that a new developer would have to pick up, it's kind of a lot, to say the least. I guess it's always been that way. We just don't look at it from our perspective. Spring is ultimately an integration framework. It combines together a bunch of different things, giving us this very consistent programming model. It began as an approach to simplify Java development, especially the enterprise variant of Java. It supports different languages on the JVM, not just Java. If you like Kotlin or Groovy, that's cool. We can make that work. It has now become this massive family of projects built on top of the Spring framework. Now, the beauty of Spring is it gives you support for almost any architecture you can imagine. Doing messages, that's fine. Doing a traditional web app, that's cool. You want to do reactive programming, we got you. Microservices, not a problem. What I love as an architect is Spring gives us choices and it gives us flexibility. So we have a consistent programming model against our data store. If it turns out, you know what, a different data store would work better for us, that's not a problem. If we want to switch out our message broker, no worries, you can go ahead and do that. The team goes to great lengths to be backwards compatible. I give them a lot of credit for this. I'm sure at least some of you experienced the joy of going from Angular 1 to Angular 2 and how much fun that wasn't. I give these folks a lot of credit for being able to make our lives a lot easier. Now, this isn't one of those things where you must be on the latest and greatest version of the JDK. I mean, they do move things forward from time to time, but they work really hard to minimize breaking changes. The APIs are well designed. They're designed by developers for developers. It is user-centered APIs for sure. If you want to know how to write good Java code, you can probably pick almost anything in the Spring ecosystem and you will see good Java code. Very well written, very clean, and some of the best documentation in the business. The other thing I really appreciate about their documentation, and this is really hard, not only does the Spring team make sure there are good things for you when you're getting started, that sort of hello world to-do list experience, it grows with you as you get more experienced. That's hard to do. Now, it's been around a while. There's no getting around that fact. Okay, this goes back to 03. So I guess it can almost drink in most countries, depending on the country. And I know a lot of developers, our first reaction when something is old is to be dismissive and say, oh, I don't want to deal with that anymore. We need to be very cautious here. All right, we always think that the old means that it's arcane and complex. It's not. Right? What we need to remember is old usually means stable, refined, and tested, whereas the new is unfinished, buggy, and unproven. We need to be very, very cautious that we're not throwing it away simply because it's old. You know, you've used JUnit. We've all used JUnit. I don't know how old JUnit is, but I think it's more than 20 years at this point.
It's more than 20, for sure.
And if you came up to me on your next Java project and said, Nate, I'm not using JUnit, I'm going to ask you why. If your answer was, well, because it's old, I'm going to push back on that. That's not a good reason to abandon a piece of technology. Now, if you're telling me you don't want to use it because you like Spock better or something, that's cool. I can understand that. But we need to be very cautious that we're not kicking something out just because it's been around a couple years. That's usually a feature, not a bug. So this originally was created to simplify JEE development, trying to give us the promise of enterprise Java beans without the additional sort of, I'll just say garbage that came along with EJB. I've tried to forget most of that over the years. That was a very painful experience. I did EJB 1 and 2, and then when EJB 3 came out, I said, nope, sorry, been there, done that. I got the t-shirt. I'm going to skip this one. It's all built around POJOs, plain old Java objects, and it is an example of inversion of control at its finest. So in other words, dependency injection. This is yet another example of loose coupling. I am very much of the opinion that the 0th law of computer science is high cohesion, low coupling. So I would make the argument that Spring really takes advantage of that. It is a declarative programming model that goes out of its way to eliminate boilerplate. I hate boilerplate. I've had some people say to me, oh, it's okay, my IDE generates it, or I have a framework that generates it for me. I don't have to type it. That's true. That's not the real pain with boilerplate. To me, it's the fact that you got to drag that along for the next 5 or 10 or 15 years. That's the pain. No, it has grown considerably from its initial days with Mr. Johnson there back in England. It's gotten quite large. Now, Spring Boot is what I think many of us think of as Spring these days, for better or worse. It's a very opinionated view of Spring, and the whole goal here is to make your life as easy as possible. Now, it's not an app server, although it does embed a servlet container. It does not implement the Java specs directly, but it'll configure beans that do. Again, not a code generator. Its goal here is to configure beans for you, freeing you from all that boilerplate configuration. Now, this all starts at the Spring initializer, start.spring.io, or as Josh likes to say, his second favorite place on the internet. His first is production, if you've not seen Josh. So what you do at the Spring initializer is you pick your language, you pick your build preferences, you pick your boot version if that's what you want to do. You put whatever metadata you want in there, what kind of packaging you're going to use, etc. And then you can pick whatever other dependencies you need. So what kind of data store are you going to use? Do you want Lombok, rinse, repeat? And this gives you a starter project, and you're good to go. Now, a lot of companies have actually taken and specialized this a little bit further, and they have, this is our set of accepted sort of collections of dependencies. So if you're going to do this kind of application, we're going to give you an out-of-the-box starter project so that you don't even have to make some of those decisions. We've made some of them for you. So some teams have actually gone and specialized, essentially, the Spring initializer. Now, if you don't like the GUI, that's fine. You can do this from your CLI. Most IDEs today actually have this baked into it as well. But you get an artifact, you open it up in your IDE, and off you go. Now, Spring Cloud looks at the world many of us live in, which says, hey, these distributed apps have a lot of the same patterns in it. So let's give you an umbrella project that has a lot of different out-of-the-box solutions for these things you are inevitably going to be doing if you are building these kinds of apps. There's a lot here. Okay, so this is the kind of defaults that you're going to want for cloud-native app development. We don't care what cloud you run on. We're agnostic to that. Same concept, you go to start.spring.io, and away you go. This is where we get our externalized configuration, as well as integration with a whole bunch of Netflix pieces. They've done quite a bit here, unsurprisingly. Security, distributed tracing, event-driven is hiding in here, deployment pipelines, discovery, connectors. I mean, we could talk about this for several hours if we gave us enough time. We'll talk more about that here in a minute. We also have Spring Data. Not surprisingly, we're going to need to talk to databases. This is a Spring approach to how do we talk to your data store of choice. This will let you talk to pretty much anything out there. The goal is let's give you a consistent programming model regardless of the underlying data store, and also make it as easy as possible for you to switch those out if you need to as your project evolves and grows. So relational, non-relational, cloud-based, MapReduced, it's all good. If you can imagine it, there's a 100% chance there's already a connector in there somewhere. Now, before I go on, we're going to have a quick demo, and we'll see how much fun the HDMI has as we swap out.
I don't use clicker, by the way, so I guess I'm not a pro.
Well, I mean, we try.
But I use HDMI cable.
You do HDMI, and you're really good at live coding, which I'm not. So that's how the system works.
It was easier before we started talking, by the way. All right, let's see. Good?
It'll show up, don't worry. Maybe, possibly. There it is.
Yes,
boom.
Yay. All right. So Nate mentioned start.spring.io. So here I'm able to auto-generate project, Spring Boot project, with a couple of dependencies. Like for instance, guess what? If you use a database and you use Java, probably you are going to use JPA. Just a quick show of hands. How many of you have used Spring Data JPA ever? All right, some of you. Yeah. Nice. So guess what? If you are using JPA, you are connecting to some sort of a database. So you will need a driver, like for instance Postgres, or maybe Oracle, or maybe H2. I'm going to choose H2. And as my friend Nate mentioned, thanks to Spring Boot, we are going to leverage the power of defaults. So the default would be, if I'm using H2, and if I don't configure that to connect to anywhere, it will try to use the default. The default would be in-memory H2 database. And I auto-generated that project before, while you were talking, by the way. That saved us like, I don't know, 15 seconds. With his pace, it's like 50 slides, I guess. About. More or less. So as you can see, I have JPA as a dependency. In my Maven, it could have been Gradle as well. I have H2 as my second dependency. So thanks to those two dependencies, the only, I would say, sane conclusion that Spring Boot can draw out of it is that this person wants to use database, and the database of his choice is H2, right? It's not magic. I would say it's engineering. It's pure logic, right? H2, JPA, I'm trying to connect to H2 database. and it's running in memory. All right, so I have an entity, let's call it credit card. I know there are better ways of storing money than big decimal, I know that, but let's choose big decimal for the sake of this demo. So I have an entity, credit card, with some sort of business methods, and I have a repo, because guess what? We are going to query, we are going to store, we are going to fetch credit cards back and forth from our database, H2 in that case, right? So if I just extend JPE repo, that gives me some sort of method by default, like I can do find all. I can do find all by ID. I can save all, I can flash, and so on and so forth. I can write a test for that, like this. Given I have some cards, I don't have any cards yet, but when I want to query, I should see 0 as the result of that query in my database. But let's change that so that we have some credit cards in the given section, right? Let's see if the test is green, by the way. Fingers crossed, it's green. So I have some credit cards in my database right now. I can change it to 2, and let's see if that works. And then we are going to do a SQL query, but I'm not going to manually code that SQL query because I'm not as good at SQL queries, I must admit that. But guess what? Spring Boot leverages the power of defaults, and probably the SQL query is super easy to auto-generate. Because if I want to query by balance, the query would be like, select from credit cards where balance greater than X, right? So I can do this. I can do all greater than X, let's call it like this. And here, I'll just type it. Find by balance greater than, and let's pass 5, which means only one of the credit cards should be picked up, right? There is no such method yet, but if I create that, Spring will auto-generate the query for me. Find by balance greater than X, whatever the X be, and now I can just check that the second query will return 1 credit card. Let's double check if that works. So how it works in the underneath is that Spring Boot or Spring Data knows that there is balance field in my entity, so it knows how to generate that query. As easy as that. The test is green and the stage is yours.
Yes.
All right.
The system works. See, the funny thing is, Jakub and I put this material together during the pandemic when we weren't in the same room. And we were doing this all virtually, so we didn't have to think about, oh, wait, you and I have different needs when it comes to how our computers are set up. And that's something we discovered on, I want to say Wednesday, when we were in Toronto, and went, oh, wait, we need our computers to be in different things. It was Wednesday, right?
It was yesterday. No,
I mean, conceptually it was yesterday,
right,
but yeah, there was a travel day in between there, to say the least.
Somewhere like that.
Now, we could continue on this path for another hour or more. In fact, our good friend Glenn put together a talk for Spring 1, the first virtual one we did, What is Spring? And I thought, well, that's kind of a silly thing to be talking about at a conference about Spring. But it ended up being, I think, the most highly attended talk we had at that Spring 1. It was kind of crazy. And it was a kind of an eye-opener to me that there's a lot of appetite and need, frankly, for fundamentals level stuff. You know, we assume everybody wants like the latest and greatest, like, ooh, what's new in Kubernetes? And it's like we forget that, you know, the basic aspects of this game are pretty important as well. A lot of good material out there. Craig Walls, good friend of ours, wrote the book on Spring, to say the least. Friend of mine, Ken Cousin, has done a lot of training in this space. We've unsurprisingly written a lot about this as well. Now, when it comes to distributed architectures, if you do not have good monitoring in place, you are in trouble. This is absolutely critical for these distributed architectures. There's 4 primary components to monitoring. You've got logging. What would you say your service is actually doing? You should log anything that's useful so long as it's not personally identifiable information. Do not ever put PII information in your logs. One of the things that makes that harder for us is some things by themselves are not PII, but when you combine it with other information, it now becomes personally identifiable. Be careful here. Tracing is also a challenge. In the old days, we'd put in a breakpoint. We would launch the code. Oh, here it is, and then we could just step our way through it. That doesn't work today, especially if I don't have access to your code. So now the call is going to bounce between 5 or 10 or 15 different services. What do? Well, correlation IDs help. Speaking of which, unsurprisingly, Spring Cloud Sleuth will help you with this problem. Imagine that. It is out-of-the-box configured to handle distributed tracing. Tracing covers all the things you would expect: spans, sampling, key value pairs, etc. It will also add trace and span IDs on the normal ingress and egress points. Also instruments those normal ingress and egress points as well. Out of the box, that will get you Zipkin compatibility. And one of the things I love about Spring is you essentially add it to your class path, and then boot just says, no problem, I got it. We also need dashboards. This is how we get a health check on our system. This is where metrics should be for human consumption. But of course, we have to make sure our alerting is in place as well. Alerting is tough. This takes time to get right. So what do we mean by alerting? Well, a key metric is now out of our normal parameters. The whole goal is to detect errors before our customers even notice them. This was a long time ago, but one of my friends actually baked a lot of this kind of stuff into an application that I actually started. And he said it was great because they would get a message from the system saying, hey, we had a problem. Their customer would call them and say, hey, I just ran into this problem. And they could say, yeah, we know, we're already working on the fix. That was a huge credibility boost for them. There will be pager duty as part of this. I'm sorry, it's got to be sustainable. Make sure, by the way, that you have clear, concise, on-call documentation in place. Do not assume the people on call know all the ins and outs of, clearing the cache. Put in the steps for how to do that. When it comes to on-call, this quote should be at the front of your mind. We do not rise to the level of our expectations. We fall to the level of our training. This is especially true when we are tired and when we are stressed. You do not see the big picture when you are tired or stressed. You get very narrowly focused. We really need to think about what it means to monitor. What do we need to have in place? What is a key metric for us? Some of those things are purely about the infrastructure that our service runs on. Am I overclocking the CPU? Have I slurped up all the RAM? How the database connection's looking? Now, that's not just going to impact us. Other things are just specific to us. Things like availability, latency, et cetera. This is things that we identify early in the project as a service level objective for us. We need to monitor errors. We need to monitor exceptions and make sure that we're not seeing a huge spike in those. Now, one of the challenges for us is we need to know what normal is. We need to know what this is starting to become an issue, and this is something really bad is happening. We need to get a human involved right now. You will not get this all right day one on a project. That's okay. You're going to need a certain amount of history to do it. I'm convinced this is part of why we're talking more and more about site reliability engineering. Don't just do this in prod. Think long and hard about doing this in staging as well. That's where we can validate that our monitors are giving us the data that we need and want. Now, metrics should be on a human consumable dashboard, but then a human gets alerted if things are really getting out of band. I do not want a human being staring at a dashboard all day and try to interpret those results. An alert would happen anytime some key metric, some service level objective of ours is no longer in the green state. By the way, absence of a key metric is also something we would want to alert on. Now, here's the challenge with alerting. Alerts need to be actionable. It needs to be something that a human has to respond to. It needs to have a sense of urgency, and it should require human intervention. It is very easy to over-alert. That does not end well. When was the last time anyone in this room responded to a car alarm? I don't even know why we bother anymore, because the alarm goes off and you're just like, please turn it off. My family, we went to a concert about a week ago. Actually, it was a week ago. And the parking lot was just this massive, massive thing, and there was no real markings, there was no signs. Like a lot of times you go to a big enough parking lot and there's like, you're in the giraffe lot, you're in, row A or something. Yeah, there was none of that. And so as, 14,000 people are streaming out of this venue, everyone's like, oh, where's my car? And so some people were just like hitting the button, making their flashers go off. But some people had the bright idea of, I'm going to press the alert button on my key fob and make the alarm go off, which meant car alarms are going off. And I'm just like, please, why are you doing that? That's really annoying to those of us who were just in a concert for 2 hours and had our ears blown out. Thanks for that. Now, by the way, if the system can fix itself, you don't need to tell a human that that happened. That's not an alert. Oh, an app instance went down and we spun up another one? Cool. You might want to put that on the dashboard. That might go to a report, and they might be looking at that periodically going, wow, this instance keeps crashing. I wonder why. We might need to investigate that. Again, that's where we get into the SRE stuff. By the way, you should be familiar with this book. It is available online. You don't need to purchase it. You don't need to read it cover to cover, by the way. It's a group of essays sort of put together over an umbrella. You can pick one up, put one down, read it over the course of a year, and you're still going to get plenty out of it. One of the things I love about the SRE book is they talk about the 4 golden signals. So latency, how long does it take for us to service a request? What is the level of demand that I'm seeing on this system right now? What's my error rate? So that could be an explicit failure, that can be an implicit failure, that can be a policy failure. And then saturation, how much of some constrained resource have I slurped up? But one of the other things we have to consider here is what should my sampling frequency be? It is tempting to always say, give me the highest resolution possible. You know, I know you and I are old enough to remember SD, standard definition TV. And then HD came out. And it was like, wow, that's a pretty big deal. In fact, I remember the first time I actually saw like HD in person, my in-laws had a very nice new TV with all the HD everything, and I still had standard def at home. And I was watching the US Open golf tournament, and I thought, yeah, this looks pretty good on my big fancy Sony TV. And then I went to my in-laws later that day and watched more of the tournament on their brand new fancy TV and went, oh my, this is hugely different. Now, I mean, today there's what, 4K and 8K and 10K, and I don't just keep putting numbers in front of K, and I guess it's just a good excuse to charge even more for a TV. Can you tell the difference? I don't know. But you may remember back when the iPod was like the dominant music platform out there, there was a aging rock star who got involved with a company trying to take over the music industry, and they created something, I think it was called Pano or Pano. My only memory of it is it looked like the Toblerone bar. It was a triangular shaped device, which, I mean, that fits really well in your pocket, right? You know, a nice little triangle sticking out of your pocket. I don't know why they thought that was a good idea. But the whole claim to fame from that is, oh, the sampling frequency is so much higher, so the music is so much richer and warmer. And, you know, and of course, audio engineers are like, yeah, no, you can't tell the difference. Like, the human ear cannot distinguish between this sampling frequency and that sampling frequency. All you've done is made the songs much, much, much larger. So same thing for us. You can, you know, turn the knobs down and see everything, but that's probably going to be overwhelming. You're going to end up having that one thing that matters is going to be lost in all the noise. So you're probably going to want to aggregate the data here in some way, shape, or form. And you'll take advantage of any number of tools that can help in this space. But if you're in the Spring ecosystem, you can also leverage Actuator. There's a whole bunch of endpoints that are baked in. You can also build your own. And that's what Jakub is going to show us now.
All right. Regarding this SD versus HD, so that you know, nobody cares about golf in Europe, really.
But, I mean, there's...
You should change the example to, I don't know, tennis.
Tennis?
Football, I'm sorry, soccer.
Soccer, yes, exactly. So I followed Premier League pretty closely because NBC bought the rights to the Premier League back in like 2014, something like that. And of course, now there's a whole show on Apple TV called Ted Lasso that I absolutely adore that's based on a character that came out of that. But who should I support if I wanted to watch Serie A? No, we don't. We're not going to get into that battle. All right.
We shouldn't ask this question out loud, I guess.
I'll be polite.
All right, let's see. The connection is lost.
The joy of swapping machines.
Yeah, let me try one more time.
We'll figure this out eventually, won't we?
Hopefully.
It's thinking.
Fingers crossed. Fingers crossed.
Maybe you need to plug and unplug. Like.
I did that already 3 times. I'm not going to reboot my laptop, by the way.
It's thinking.
Can I use your dongle?
Sure.
Maybe it's going to be...
We could try dongles. We're going to dongle switch.
Yeah, let's do that.
Apologies. Technology works. Technology is great right until the technology doesn't work. And then it's like, why did we get into this line of work? Maybe now we're stressing out the poor projector. Because it's like, why are you
I have no idea. Weird.
This worked really well on Wednesday.
It worked 10 minutes ago.
Yeah, exactly. Well, come on.
Come on, come on.
I guess I could do jazz hands. Where's the? Do we need a new HDMI cable?
Can we get any help?
Do we have AV support? Maybe not.
Doesn't work.
Oh, hello.
That's so weird.
Right. Well, should we try plugging back into mine, see if that works even? Did we break things? We're sorry.
One last try.
We weren't trying to break anything. We're not good at that.
Let me try display. Doesn't work. Oops.
Huh. This is what we get for trying to be fancy, Jakub. We should have just presented off your machine.
Yep.
That's on me. That's on me.
All right.
If we get that to work, I'll just switch over to your machine. It'll be fine.
It doesn't work.
All right.
Let's try your computer.
Well, let's see if I can even present anymore. Maybe we'll just have to jazz hands our way through the rest of the day.
Sorry for that.
Only halfway through the model. It's thinking.
Doesn't work.
I think we broke. Oh, wait, there I am. Okay,
Weird.
so mine works.
That's so much.
So your machine, it's your machine. Works on my box.
But the demos are on my box.
Well, do we want to try? Do you want to reboot and then?
Yeah, you continue
we'll come
talking.
back to actuator. All right.
Yeah.
Moral of the story, friends: metrics cannot afford to be a hand-rolled solution. They can't. You have to have consistency here. Take advantage of the baked-in endpoints. Build your own as necessary. We need consistency across our projects. Now, this is one of those things that you're going to have to spend some time working on. Right? This takes some time to get right. Do not expect to get everything right on day one. Again, I'm convinced this is why people are talking so much about SRE these days. Now, the other thing you need to be very cautious of is that you're not getting stuck with a metric that's easy to measure. Just because it's easy to measure does not, in fact, mean it matters. This is one of those fascinating aspects of this, right? Lines of code. How many times have you seen someone said, you know, oh, we're going to judge you by lines of code? As a developer, I'm like, great, because I know how to game that system. Thank you very much. Have you ever heard of the Hawthorne effect, by the way? That's an interesting sort of mental, I don't know, fallacy is not quite the right word, but they did this study many, like 100 years ago to see, hey, if we improved the lighting in this factory, would that improve productivity? And sure enough, it did. They thought, well, there's the thing. Just increase the lighting, better lighting, and everything gets better. And then they tried that, and it didn't work. And they're like, well, this is weird. And what they ended up figuring out is the Hawthorne effect says basically you change behavior simply by measuring it. Same kind of thing. We need to be careful that we're not changing behavior for the wrong reasons. We also need to understand business drivers. And how do we map that to our services? This is one of the big challenges we have. What happens when we get, I don't know, 10x the number of orders, or 10x the number of customers, or 10x the number of signups? What does that mean to the services? How does that impact the services? We also sometimes need to realize how the technology can impact the real world. This was, I think, 2 or 3 weeks ago. I don't remember which company it was, but one of the delivery services that works with restaurants decided to offer a deal in New York City that said, hey, we'll give you $15 free for lunch. Order whatever you want off the system. So what happened? And this was limited time, right? From like 11 to 1, you had to place your order. So at 11 o'clock, guess what? A whole bunch of orders started flooding in. Now, the technology had no problem scaling up to do that. But you know what doesn't know how to scale up like that? Restaurants. And so all of a sudden, restaurants were getting hundreds and hundreds and hundreds of orders. Like I saw some of the pictures, like the orders were just like piled up. They didn't have enough food because they weren't expecting that. You know, most restaurants have a pretty good idea. These are our busy days. These are our busy hours. This is how much we're going to go through at this period of time. They weren't prepared to get thousands and thousands and thousands of orders. There also weren't enough delivery people to go and pick them up. So food just sat there. And of course, the company that put this out, they're like, yay, the technology worked. And like, oh, wait, we forgot there's a real world impact to what we just did. Sorry about that. And so, of course, a lot of these restaurants were the ones that took the heat because, you know, you ordered your favorite thing. It's like, it's not here. It's the restaurant's fault. Oh, no, it wasn't the restaurant's fault. It was the technology company that didn't realize, oh, wait, that's right. This is going to impact the physical world. You also need to be realistic here, friends. It's very tempting to be like, oh my gosh, you know, we're a rocket ship going to the moon and, you know, we're going to do all sorts of amazing things. We cannot all be a third of internet traffic. That's not how the game works. I'm sorry. A lot of information out there on this space. This actually, our friend Jonathan did a thing on Wednesday on monitoring. We talk a lot about it. It's very, very important stuff. There's no getting around it. Please make sure that you've thought through what your monitoring looks like. Do you just want to use my dongle? Would that be the easier way to do it?
Yeah, that's right.
Should we try it again?
Yeah.
All right, we're going to try it again because, you know,
I rebooted. So
we're chaos engineering on the fly.
most of the problems can be solved with rebooting, right? Let's see if the failing projector can be solved with rebooting. Fingers crossed.
Maybe. Wait, I saw your machine blink.
Yes.
Yay! Yes!
All right.
80% of our problems go away by rebooting. That's why state management is a
Of
solved
course.
problem.
That was on purpose, by the way.
That's right.
All right. So we're talking about
inspired by your talk.
actuator, right? Actuator. So
Yeah.
as you can see, I have two more dependencies. One of them is Spring Boot Starter Web, which gives me embedded container. Right? As Nate mentioned, it's gonna start by default using Tomcat. I have already started that. As you can see here in the log statements, here is started demo application port 8080. I also have dependency to actuator, which gives me huge amount of operational information exposed via either JMX or web. I chose web because it's easier to demonstrate. All right, so we have many different endpoints baked in. Like, for instance, I can do /actuator/beans, so I will see all of the beans which are registered. As you can see, many of them. I also can take a look at the loggers. For instance, what are the levels and so on and so forth. Loggers, all of the loggers. I can take a look at what else? The health check, for instance. I think it was /health. Yes, the application is up. Cool. Some sort of information which I haven't provided, so it's empty. I can do, I don't know, thread dump, something like that. I think so. Which might not be so secure. By the way, it integrates very nicely with Spring Security because you would like those endpoints to be secured. I disabled that on purpose. Don't do that at home, all right? So I disabled security for the sake of this demo. All right, maybe there is some sort of an information that you would like to provide, but it's not given by default thanks to actuator. Am I pronouncing that okay? Actuator? I always have problems with that. Actuator, all right? So you are welcome to create your own custom endpoints. For instance, this is a custom endpoint which will create random numbers. As you can see, the only thing I need to do is to register that as a Spring bin and also say that, hey, this is going to be an endpoint that will be exposed thanks to actuator. It might be JMX endpoint, as you can see. It might be web endpoint. It might be both, like this. ID of this endpoint will be, I don't know, random, and you will have read operation in here, which means if you now hit /actuator/random, it will run this method. Of course, contrary to read operation, you have write operation with, for instance, HTTP post, if you would like to change something in your operational information. All right, let me rerun this application and see if 8080/actuator/random gives us random numbers. Hopefully, we'll see that. All right, let me go back to the browser. Not thread dump, but random. As you can see, oops, yeah, there are random numbers.
Just tiny.
Here, tiny random numbers. All right, let me hit one more time, and fingers crossed, this time the handover will work without any issues.
We'll do it live, as they say. Fingers crossed. Blink, blink, blink. There we go.
Yes.
And one more blink. Boom. Yes.
Fault tolerant, right? Tolerance.
It's all about being fault tolerant. All right. Should be pretty obvious. Distributed systems are not, in fact, islands unto themselves. Things will fail. To paraphrase my favorite fictional chaos mathematician, failures find a way. Our customers don't care, by the way, why something failed. They just get mad at us for things going down. We cannot prevent all bad things from happening. Nature of the beast. But you can be prepared for when a bad thing happens. So how should we react? Should we kick back an error message? Should we fall back on some other service? Should I have some cache data? Do I just return 42?
Or reboot.
Or reboot. Always reboot. There are 3 answers to every question you've ever run into in computer science. There's 42. That's to see who's well read. My favorite pattern as an architect, another layer of indirection. But the answer that I have to give more often than not is it depends. Now, some people get mad at me when I say it depends. I do not mean it, by the way, as the end of the conversation. It's the beginning of the conversation. It depends is something I say so often as an architect. A friend of mine had a T-shirt made up that said it depends on it. And he wears that a lot of times when he presents. I told my grad students last fall the answer to every question this semester will be it depends. And they caught on to that immediately. I'm very proud of that cohort. This is where the circuit breaker comes into play. Now, this is something that Michael Nygaard talked about many moons ago in his seminal work, Ship It. The basic idea here is just like the circuit panel in your house. Oh, this circuit is overloaded. Let's open it up to make sure that we're not going to burn out everything going on around here. So in our world, the circuit breaker watches the call, and once we exceed some failure threshold, we open the circuit to prevent more bad things from happening. There's no point in us calling this again and again and again and again if things are failing. So bad thing goes on, great, let's redirect to whatever fallback method you identified. And then let's periodically see, are you healthy? Are you healthy? Are you healthy? Oh, you are? Cool. We'll close the circuit and go back to our regularly scheduled programming. There are a whole bunch of different implementations out there to pick from. Spring Cloud Circuit Breaker actually is a nice layer over the top of that so that you as an engineering team can have a consistent programming model and change things to your heart's content. It gives you this consistent API and let your development team pick whatever implementation is right for them, whether that's Hystrix, whether that's Resilience for J, Spring Retry, etc. Like so many things in this ecosystem, you put the proper starter on the class path, you call the factory, and now you inject that wherever you want in your code. Each individual circuit breaker can be configured to your heart's content. You can also create default if you wish. All of the normal things that you would want to modify are in there: thresholds, slow call thresholds, number of calls, your window size, etc. We're going to tempt fate twice more.
All right.
And then see what happens. Wait for the blink. Blink, yes, that's a good sign.
We're good, we're good.
And one more blink, blink.
All right, so now a tiny
Blink
credit card application, we also have, guess what, risk check. And let's say we are exposing /evaluate to do the risk check, but we are not doing that on our own. We are delegating to a third-party system via HTTP client, all right? And this failing risk client will return manual, but soon it's going to down-perform. We are going to simulate the down-performing part very soon, but first, let's see if I'm able to get manual if I just do curl localhost 8080 evaluate. As you can see, it works, so we are delegating to the third-party system, but as already mentioned, this system, has its bad days. And for instance, we have to wait 300 milliseconds to get the answer, all right? So it's a simulation of a blocking call. We have to wait for the third-party system that we are calling via HTTP. I'm going to do this just for the sake of the demo, okay? All right, you okay with that? Okay, cool. Just for the sake of the demo. And then, even though we waited 300 milliseconds, the system, the risk management system, or however we call it, is going to return an error every now and then. Let's say 50% of the calls will end up with the exception. Or you know what? Let's make it 75%. And only one of each 4 calls will be successful given us in the actual answer. All right, let's run this application right now and see what happens if I hit /evaluate. The application is up right now on port 8080. All right, so let me do curl one more time. Exception. Oh, this time we are able to get the answer. But if I, for instance, do much more calls. To do so, demonstrate many clients hitting our application, I'm going to use a tool AB. Anyone has heard about AB, Apache Bench tool? All right, so it gives me 100 calls to localhost 8080/evaluate. So if my math skills are fine today, every call lasts at least 300 milliseconds, multiply by 100, at least half a minute, right?
Sounds about right.
We have like half a minute.
How was your flight? Is that all right?
Awful.
Awful?
I don't want to talk about it.
I had the joy of my transatlantic portion of my flight over here of having not one, but 2 infant in arms in my row. There is a special circle in hell for people who are traveling with infants on transatlantic flights. I assume there must have been some very critical need to transport an infant on a transatlantic flight because there is no way to reason with a 3-month-old about why their ears hurt. And they don't have any other reaction than crying randomly, actually just kind of like random failures. But it made it really easy to not sleep. Your
flight was worse than mine in that case, to be fair. We have failed requests, 23, which is okay. Every one of, I mean, some calls were successful, some of them were not, like 7-7. It's more or less 75%, right? Each of the calls lasted at least 300 milliseconds, which is nice. So now I'm able to use circuit breaker because I don't want to call this risk management system if it's down-performing, if it's returning exceptions all the time, by the way. So to do so, I will need to configure a circuit breaker. So for the sake of the demo, I'm going to do that in a constructor, all right? Normally, you would have an external class to configure that, and also to speed things up, because we have like, what, 1 minute or less? More? 1 minute? I'm going to copy-paste some configuration code, like this. I will have the config for the circuit breaker, as you can see, with failure rate threshold like this, I will have the time config as well, and I will have the resilience for J, because that's my implementation, that's implementation of my choice, bootstrap with those two configurations, time limiter config and circuit breaker config with some sort of data. All right, so last thing we are going to do, I'm able to create the circuit breaker right now, like this. Let's call it, for instance, maybe evaluate, why not? Evaluate, all right, like this. Let me create that field in here. So now I'm able to surround this call in a circuit breaker, like this. Run that part of code, all right. I'm able also to do, for instance, a default response. If the risk management system is down, I could return manual. Let's not do that. And let me rerun the application and do the Apache benchmark tool one more time, the test, and see how long it takes right now. All right, the application is up. Let me clear this out and see. It should be quicker, right?
I would hope so.
Because we are not calling the risk management.
Patient. Oh, yeah. There it is.
As you can see, 50% of the calls lasted less than 4 milliseconds. So there is no way we actually have called the failing risk management system. We have returned an error or default response immediately to the client, which makes our customers more happy, right? All right.
Awesome.
Let me switch to...
That's it. That's all the time we have.
We have 1 minute.
We have 1 minute, or we're over a minute? What's -1 mean? All right, well, friends, I hope that was helpful. Thank you so much for hanging out with us. Really appreciate it. Sorry for the technical glitches, but, you know, hey, this is what happens when we're live and in person again. So thank you so much for hanging out with us. We really appreciate it.
Thanks.
Cheers. Ooh.